Okay, thank you everybody in the audience and everybody online as well. It's a real pleasure to introduce Caoimhe and Jess, who are the Mathematicals. So Caoimhe and Jess met here in Oxford in 2015 doing PhDs. So first of all, about Caoimhe, she grew up in Belfast before undertaking her undergraduate degree in pure maths at Trinity College, Dublin. And she then came to Oxford to do her PhD in Infom and is now a postdoctoral research fellow at NASA Ames. And she works on the modelling of clouds around planets outside of our solar system in order to understand how they formed, what they're made of, and ultimately if the planet could contain life. And then Jess is originally from England, but she grew up in California. She did her undergraduate degree in mathematics and life sciences at UCLA before coming to Oxford for her MSc and then PhD, also in Infom. She stayed in Oxford for a further 6 months for a postdoc before taking up a postdoc at MIT in the cardiology lab to determine aortic shape and flow abnormalities. And she now works as a scientist for Boston Scientific Corporation, where she uses a mixture of mathematical modelling and experimentation to help design neurological devices. So with that, I will hand over to both of them to talk for us today.
Thank you, Ian. We're so excited that you invited us here to talk about an initiative that we started called Mathematigals. As Oxford alumni, we were really motivated by a lot of the outreach activities that we saw taking place at the university and wanted to start our own platform to increase the representation of women in maths, make maths fun and exciting, and showcase its many applications. For those of you who don't know us, I'm Jess and this is Caoimhe, and it's extra fun for us to be giving this presentation together as we're currently 3,000 miles apart. I'm in Boston and Caoimhe's in Northern Ireland. And actually Mathematigals has been an entirely remote collaboration, as many projects have been over the last couple of years. And as Ian described in his introduction, I was a part of the Oxford Maths department from 2014 to 2020. I came in 2014 to do a one-year MSc in mathematical modelling and scientific computing and just didn't want to leave, so stayed for another 5 years after that to do a PhD and then to do a 6-month postdoc. And in general, I'm just interested in all ways maths can be applied to medicine. When I left Oxford at the beginning of 2020, I worked as a postdoc in a cardiology lab at MIT. And I was using a combination of fluid dynamics modeling, which was something I worked on during my PhD, and also image analysis techniques to look at different aortic shape and flow abnormalities that could be indicative of aortic dissection. And then just at the end of September, I've started a new job. I'm working at Boston Scientific Corporation, which is actually the company that sponsored my PhD. And I'm working particularly on designing neurological devices. And it's been a really exciting transition to see how I can take some of the theory and modeling I worked on during my PhD and actually apply that in a context that it can be used to design these devices and hopefully bring them to market.
And I'm Caoimhe. So as Ian said, I was at Oxford for my PhD between 2015 and 2019. And there I worked on electrical furnaces and trying to understand how they operate. But my real passion is maths within space. So I'm currently a research fellow at NASA, but starting January, I'm going to have a new position there as a research scientist. And what I work on there is trying to derive and develop mathematical models that will help us understand how clouds form around these planets. So when we look at these planets with a telescope, we can't make out any sort of resolution. It's not like looking at Mars or even Jupiter. You can only really see the light that's being reflected off that planet. So in order to understand exactly what that planet is made of, we have to understand if there's clouds around that planet, because those clouds can scatter the light in different ways. So knowing how the clouds have formed and how they behave around the planet can help us interpret that light spectra that we get back from the telescopes in order to understand what these planets could be made of and if they could harbor life. But before we really get into what Mathematicals is and what we're doing with it, I want to give you a bit of a thinking exercise. So have a look at these 3 people and ask yourself if you can name them. So don't have to shout out or put anything in the chat, just have a think if you recognize them and if you happen to know their names. So I'll give you a second to think about that. Okay, so on the left, we have Pythagoras. In the middle, we have Alan Turing, and on the right, we have Paul Erdos. So now that you know their names, can you have a think about why they're famous? What did they do to earn a position on this slide? So I'll give you another little minute. Okay, so a very easy one is Pythagoras. I think most of us are familiar with Pythagoras' theorem. Then in the middle, Alan Turing was cracking German ciphers in the war. He was a very talented cryptanalyst. He played a key role in developing what is now the modern computer. And then finally, Paul Erdos was one of the most prolific mathematicians of the 20th century and has published at least 1,525 papers during his career. Okay, so I'm going to ask you the same question, but for 3 different people. So have a think to yourself, do you recognize any of these 3 people? Okay, so there on the left, we have Sophie Germain, in the middle, Emmy Noether, and on the right, Julia Robinson. So again, now that their names have come up, does that maybe spark within you what they might be famous for? Have you heard of these people and know what they did? Okay, so they're all mathematicians and they've all been pivotal in proving important theorems. So Sophie Germain was the first mathematician to ever formulate a cohesive plan for proving Fermat's last theorem. So she gave a big helping hand to our own Andrew Wiles when he eventually proved it himself. Emmy Noether proved Noether's theorem, which is an important part of theoretical physics and the calculus of variations. And Noether was described by Einstein as a creative mathematical genius and the most significant woman in the history of mathematics at that time. And then Julia Robinson, the only one that's still with us, she played a critical role in proving that Hilbert's 10th problem is unsolvable. And she was also the first woman to be elected to the mathematics section of the National Academy of Sciences and the first woman president of the American Mathematical Society. So here we have 6 incredible mathematicians, but did you know all their names? Did you know what they did? When I speak for myself, I was certainly more familiar with the men than the women, and that's certainly not because of mathematical accomplishment. So why is this? Why is it that Germain, Noether, and Robinson are not as well known or not as celebrated as they maybe should be?
So this brings us nicely to our main aim of Mathematigals, which is really to increase the representation of women in mathematics. And although that's our main aim, we do have 2 other aims for Mathematigals that we actually think go hand in hand. So alongside increasing the representation of women, in order to encourage more young people to go into the field, we think it's really important to try and push how fun and accessible maths can be, and to take it out of the classroom and showcase it in the many ways it can be used in everyday life. We feel that one of the big barriers to maths is the stigma surrounding it and the fact that it's often sort of thought of a subject that's not particularly applicable, and many people ask how they can use it in everyday life. And so that's one of the things that we really hope Mathematigals can do, is to show some of those ways that it can be used.
Okay, so we mentioned representation, and why does representation matter? So we've all heard the phrase, you can't be what you can't see, and we're aware of this systematic push to get more women in STEM fields. So how does representation help with that? So there's a concept called brilliance bias, and that's this tendency for people to think of brilliance as generally a male trait. So with fewer women being recorded in the history books, brilliant people come to mind. When you think of a brilliant person, you're more likely to think of a man. And this stems way back into very early age groups. So this underrepresentation has consequences. And we've seen that in careers that are generally understood to require brilliance to succeed, such as physics and maths. And they're generally likely to have fewer women working within them. So let's ask the uncomfortable question. Are women just worse at maths than men? Is that why there's this gap? Well, the answer is no. But studies have shown that an unconscious bias against women is prevalent within both sexes. So actually both women and men underestimate women's ability to do maths. So a recent study showed that from primary school onwards, this unconscious bias was causing mathematical competence of girls to be underestimated by teachers and parents. But this is not just an external phenomenon. So in a study led by Professor Catherine Kaufman of Harvard University, participants completed a timed assessment where they were tested on 5 cognitive areas. That was general science, arithmetic, mathematical knowledge, mechanical comprehension, and the assembling of objects. And they were asked to guess their total number of correct answers, and also how they believed their performance would rank compared to the other participants. And one of the conclusions of that study was that there was a woman who had the same score as a man, but she had estimated her score to be 0.58 points lower. So out of context, we don't really know what 0.58 points means, but it was quoted to be a statistically significant gap. So even though they had performed equally, she had believed that she wouldn't do quite as well. So are women worse at maths? No. Women often lack confidence in their ability to compete in fields that men are stereotypically believed to perform more strongly in. So women are undermining themselves as well. And this is stemming into early childhood and the gender gap, which Jess is going to talk about. But when we looked at some other studies, so these studies were done on sort of older age groups, and we looked back at children, and children were asked to draw a scientist. And there were a number of studies that used this experiment, and they found in study number 1, they found that 28 out of 4,807 drawings were female. So only 0.7% of the total drawings of scientists were of a woman. And 100% of these drawings were done by girls. A second study with the same experiment showed that 8.4% of the total drawings were of female scientists. And then in the final study, which was slightly better, we got up to 32% of the drawings being female. But you'll see for each of these studies, the majority of the drawings that were of women were by girls. So we've got this discrepancy between how young people are picturing scientists, and they're generally coming up with the conclusion that to be a scientist, you have to be a man.
Well, I think it's interesting for us to think about how this gender gap forms and where it initially starts. So if we sort of start by focusing on early education, and here thinking about girls and boys between babies of 6 months and 8 years old, and many studies have shown, hopefully quite unsurprisingly, that there are no differences in mathematics motivation or ability between girls and boys at an early age. And specifically, a recent study actually tested many different metrics for motivation and many metrics for ability. And one of the metrics for ability in young children is they tested their numerosity skills, and they looked particularly at 5-year-olds. And essentially the way they tested it is they showed them 2 groups of objects, one which had more objects and one which had less objects. And these 2 groups had lots of objects in them, so they were not countable to these young children. And so here I'm only showing 4 and 2 as an example, but really it would maybe show 16 on one side and 30 on the other. And they calculated something called the Weber score, which is basically saying the number of objects in the large group minus the number of objects in the small group divided by the number of objects in the small group. And then basically that gives an indication of how big of a difference there needs to be between these 2 groups for the children to determine that difference. And what these 5-year-olds had to do is they had to pick the group that had the larger number of objects. And they calculated for lots of children, over 500 children, essentially how big this ratio needed to be in order for the children to discern which group had more. And here it was shown that the Weber fraction was 0.56 for boys and 0.58 for girls, with no statistically significant difference between the 2 groups. And that's just an example of one of the metrics used. It's an interesting paper, and they use lots of different metrics, but really the conclusion is the same over all of them, that there's no differences between boys and girls at this age in mathematics. So moving on now to high school or secondary school, this is where we actually see the gender divide start. So we must assume that something happens between those early ages and when children get up to high school and secondary school that means less girls are pursuing maths. For instance, the statistic here is actually on the number of female A-level candidates in the UK. And that number, so on the left in this plot, we actually have the number of maths A-level candidates in thousands over the last 10 years from 2009 to 2019. And we can see that that number has been steadily increasing. So there's been more people in total who are taking maths A-level. But then on the right, we see the proportion of that group who are female. And we can see that it's sort of hovered around 40%, just under 40%. And in fact, over the last 10 years, we would have liked to have seen that number increasing, but it's actually, if anything, been decreasing. And it's now at about 38% of A-level candidates taking mathematics being female. And just to show that this isn't just a UK trend, but it's actually something that's seen universally, there's this competition called the International Mathematical Olympiad. It's a competition taken by pre-university students all over the world, and usually the finals are held in different countries. And here's a plot of the percent of those mathematical Olympiad candidates who are female. And it's over the 50 years since the inception of this competition in 1959. And you can see that it's only ever been up to about 10% at the most. And that number's sort of jumped up and down a little bit over the last 50 years. And as an actual statistic in the last years from 2000 to 2021, an average of only 9.2% of the International Mathematical Olympiad candidates have been female. And unfortunately, again, it doesn't really, we can't sort of discern a trend that seems to be increasing. So that's interesting to note. And finally, moving up to university and beyond. So starting with a statistic actually from Oxford, as probably many of us are aware, 27% of mathematics undergraduates in Oxford are female. And when we look at the UK as a whole and we look at maths PhD students, only 19% of maths PhD students in the UK are female. And then when you move into professors, only 6% of maths professors in the UK are female. So that's a general trend that is quite well known, that this number seems to narrow as students move up. So there are still a relatively low percentage of mathematics undergraduates that are female, but that number decreases further with students who are pursuing graduate studies, and then those who then decide to move into careers in academia and become professors. That number decreases even further. So we've thought quite a bit about what reasons could be for the gender gap, and we've read the thoughts of other people, and it seems three things sort of stand out to us. One of those is stereotype threats. So Caoimhe sort of mentioned this a little bit. It's related to the brilliance bias in a lot of ways, but basically stereotype threat can occur when there's an opportunity for someone to complete a task of which they are part of a stereotyped group in that task. And that basically provides them an opportunity to confirm a stereotype. And due to the pressures that induces internally, it often means that that person will perform less well on that task. So that's very relevant in mathematics, where there is still a stereotype about women in mathematics, and that can often be sort of considered internally for a woman in their mathematical abilities and lead to a reduced performance. And then unfortunately, that's a bit of a vicious cycle, because there's a reduced performance, which leads to less interest in the subject and perhaps leaving it altogether. And a second reason that contributes to this gender gap is some preconceived notions about who actually pursues STEM careers. And interestingly, there was a recent Stanford study that showed that actually high school groups in more affluent communities tended to have a larger discrepancy between the genders and in terms of numbers of boys and girls pursuing mathematics. And their hypothesis around why this was occurring is that these more affluent communities, parents were often more able to enroll their children in extracurricular activities, maybe things like robotics camps or dance classes, which are typically still gendered. And those could sort of plant those seeds about what students go on to pursue STEM careers, and the fact that that's a boys activity, and then that sort of perpetuates into as these children grow up. And then finally, another reason that's often reported is actually testing formats. So it's been shown that multiple choice testing in particular, women are less likely, do less well on multiple choice tests. And that might seem surprising, but actually the reason for that is just because women are often less likely to guess on multiple choice tests. And say if you had a multiple choice test that only had 4 answers, obviously if you didn't know the answer at all, you'd have a 25% chance of getting it right. And if you don't take up that opportunity and you don't guess and you don't give any answer, you have a 0% chance of being right. So actually just that sort of wariness around guessing means that females often perform less well on multiple choice tests. So now we've considered those 3 possible reasons for the gender gap, we can think about what are ways that we can combat that. And that's something that we're hoping Mathematicals is doing for each of these 3. So starting with stereotype threat, we think one way to combat that is to really increase the representation of female mathematicians and showcase the work that many women are doing in the field. And so as we've mentioned, that's really the primary goal of Mathematicals. And in terms of sort of breaking down barriers and ideas about who pursues STEM careers, we hope that by showcasing the many ways maths can be used and the completely diverse lives that mathematicians lead and the diverse fields that they contribute to, we hope that that can to help to break down the concept that there is a certain type of person who pursues mathematics. And Caoimhe and I love that we've had quite a similar background in maths, but we're working now in 2 quite different fields. So we hope that by talking a little bit on our platform about what we do, that shows that maths can be taken in many directions. And then finally, testing formats and breaking away from that. We think that the way to do that is really just to try and bring maths outside of the classrooms. And as we all know, as mathematicians, mathematics is actually an inherently creative subject, and especially thinking about topics like mathematical modeling, there's a lot of creativity that goes into that, but that's not necessarily something that's introduced at an early level where you're just learning the fundamentals and the equations and the tools you might need later on. But we think that it's a great idea to be able to introduce some of those early creative aspects to maths at a younger age and move away from that sort of regimented multiple choice answer idea of mathematics.
Okay, so social media is now on your screen, which maybe seems like a bit of an odd jump from talking about the gender gap and talking about female representation. And actually, when we started Mathematicals, we didn't really set out with an agenda to become social media influencers or to be overly active on social media in any capacity, but we quickly realized that this is the primary avenue at reaching our audience. So social media is a hugely powerful and quite scarily influential industry. So we started to take a look at how we can exploit this to reach more young people. So to demonstrate this huge influence of social media, there are currently 4.6 billion social media users worldwide. And that's 59.5% of the current world population. And actually, more children are on it than you'd probably like to think. Within the age group of 5 to 7, 30% of UK 5 to 7-year-olds are on social media. And when you get up to the 12 to 15 age group, we already have 87% of that age group being active on social media. So they're using it. There's no getting away from it. So we wanted to have a look at what are they seeing and what are they being influenced by. So we took a look at the most followed female Instagram influencers. And at the top of the list, we have Kylie Jenner, then Ariana Grande, Selena Gomez, Kim Kardashian, and then the list continues. So what we're seeing here is a lot of models and a lot of pop stars. So we thought to ourselves, maybe this isn't a very fair metric to be expecting to see some scientists in, because these women are also incredibly famous, that they will naturally have more followers. So instead, we decided to look at the most followed science Instagram accounts. And we see incredibly inspiring and influential people like David Attenborough, Bill Nye, Thomas Pesquet, who I personally love and whose Instagram is amazing. But although these are great accounts to follow, they're still all men. So even though the content is out there, the top science accounts are still men. So the space for science in social media is being used, but it's being dominated by men. So on social media platforms, the overwhelming majority of female influencers are beauty bloggers, fashion queens, and Instagram models. So girls are being fed a very definitive picture of what they should be. And there's still this disparity between what boys should aspire to and what girls should aspire to. And this is not playing. Let me give it one more go. Okay, so we're trying to change that narrative a bit and show girls that in an industry where we're told to be picture perfect pretty, that we are much, much more. So we want to use the tools and the power of social media to showcase ordinary women. So not famous, rich women, but regular people doing interesting and fascinating things in science and maths. And this is where representation matters and where we want to be present to dilute that exposure of perfect pictures of idyllic lifestyles and physical appearance.
So this moves on to what are we actually doing right now with our platform? Well, actually, our initial motivation was just to create fun and informative videos on mathematical concepts and curiosities. And that is still the main thing that we're doing. Actually, through doing this, we've realized some very nuanced aspects of posting videos on social media. For instance, aspect ratio matters. We were initially posting videos that were the aspect ratio of a laptop screen, but finding that those didn't get so many views on the platforms we were putting them on, and realized that instead posting videos that did the aspect ratio of an iPhone screen that people can naturally scroll through actually get a lot more engagement. So we've decided to separate our content. So we produce shorter videos that are sort of scrollable in an iPhone screen ratio, and then we produce slightly longer videos that go more in depth into mathematical topics on the ratio of a laptop screen. So one thing we've started, and we try to post one of these once a week or so, is something we've started a hashtag 1 minute maths. And these videos are usually 60 seconds in length, and they're introducing some fun mathematical topic. And usually they're done in an animated way. We make the animations and we share doing the voiceovers for them. Sometimes they're videos of ourselves explaining a topic, or sometimes they're written videos. Keith will show an example of that in a bit, but we're just going to show a few of our videos today, if that's okay. This is the first one. It's an example of one of our 1 minute maths videos, and this is explaining the birthday paradox, which you might be familiar with.
In a group of 23 people, what would you guess is the percent chance that at least one pair share the same birthday? Got your guess? It's more than 50%. Are you surprised? Let's see how we figured this out. There are two options. Either everyone has a different birthday, or at least one pair share the same birthday.
To find the chance that there is at least one pair of shared birthdays, it's easier to first calculate the chance that everyone has a different birthday and subtract that from 100%. For a group of two people, the chance that they're born on different days is 99.7%, so the chance that those people have the same birthday is 0.3%. We can apply the same logic to bigger and bigger groups. So for a group of 23 people, there is a 50.7% chance that at least two of them will share the same birthday. Why not try it yourself for a group of 75 people?
It's more likely than you'd think, isn't it?
So we usually end our videos with something like that, which is a challenge or a question for the people who are watching. And so people can often comment the conclusion to whatever we've asked. And so that's an example of one of our short videos. And here's another example that Keeper will show.
Yeah, so we started posting these, and Jess mentioned earlier with our larger landscape ones, we were posting these on Instagram, and really we weren't getting the extremely positive feedback that we were kind of expecting. And we sort of realized that how the young people are using Instagram and using TikTok is slightly different from these animated videos that we sort of favored. So we started to try and change our style a bit and do more, actual videos of either us speaking and explaining a concept about a mathematical problem or a bit of technology, or us writing on an iPad. So this is one that we did recently that outlined a quick trick about calculating percentages.
Here's a really simple trick to help you calculate percentages instantly. What if I asked you to tell me 12% of 25? That's a thinker. But what if I told you that the numbers could be reversed? So instead, find 25% of 12. Well, that's a lot easier. It's 3, which is the same as 12% of 25. Let's do another one. What is 44% of 50? Well, just reverse the numbers and find 50% of 44. 22, easy. And finally, some bigger numbers. What's 80% of 150? That's the same as 150% of 80, which is 120. Problem solved.
And then finally, we do have our slightly longer videos that are usually a few minutes in length. And these are really the ones we're most proud of. They require the most work, and they usually have much more animation and information in them. And with these videos, we actually try and address all three of our goals. We try and address representation of women, we try to address making maths fun, and we try to address showcasing some sort of unique application. So the video we're going to show of this style is on the Monty Hall problem, which I'm sure a lot of you are familiar with.
Welcome to the Mathematigals show with me, your host, Marty Hall. Please welcome today's contestant. Give her a huge round of applause.
Thanks for having me on, Marty.
Here's how the game works. You'll see we have 3 doors. Behind 2 of the doors are goats, and behind the 3rd door is something you really desire. Let's say equal pay for women.
So I just guess which door I think equal pay for women will be behind?
Exactly. Now, which door do you choose?
Marty, I choose door number 1.
An excellent choice. But before I reveal whether you're correct, I'm going to give you one chance to change your mind. Let me show you that behind door 2 is a goat. Do you want to stay with your original guess of door 1 or switch to door 3?
Although intuition might suggest I've got a 50-50 chance of winning either way, if we look more carefully, we'll see that I'm actually more likely to win if I switch to door number 3. Let's look at why that's the case.
Here are our 3 doors, and we initially picked door number 1. There are 3 possible scenarios as to where the prize is. It could be behind door 1, behind door 2, or behind door 3.
In the first scenario, we guessed correctly, but remember, we don't know that yet. The host will either open door 2 or 3 to reveal a goat, but either way, we'll win if we stay, but lose if we switch.
In the second scenario, where we pick door 1 but the prize is behind door 2, the host will open door 3 to reveal the goat, so we'll lose if we stay but win if we switch.
In the final scenario, where we picked door 1 but the prize is behind door 3, the host will open door 2 to reveal the goat, so we'll lose if we stay but win if we switch.
Tallying these up, staying will result in a win in one of the 3 scenarios, whereas if we switch, we will win in 2 of the 3 scenarios.
That's equivalent to saying the probability of winning if we switch is 2/3, and the probability of winning if we stay is only 1/3. So in general, it's a better tactic to switch than stay.
This problem is known as the Monty Hall problem, and it gained a lot of attention in the 90s.
Marilyn Vos Savant, a woman listed in the Guinness Book of World Records for having the world's highest IQ, established Ask Marilyn, a weekly column discussing a variety of academic questions and logic puzzles.
In 1990, Marilyn devoted one of her columns to the Monty Hall problem and correctly explained that switching doors would maximise your probability of winning.
She used the analogy of having 1 million doors, and after picking door number 1, the host, who knows where the prize is, opens every other door except for, say, door number 777,777. You'd probably feel safer switching to this door than staying with your initial 1 in a million chance choice, right?
However, she was met with the wrath of outraged academics claiming she was wrong. In fact, she received more than 10,000 letters, nearly 1,000 from those with PhDs, all to the tune that she was entirely incompetent.
They were all convinced that once the choice was down to one of 2 doors, it had to be a 50-50 chance. It's clear that I've got the best chance of winning if I switch. I'll go with door number 3, Marty.
Door number 3 it is.
Oh, but it looks like we're all out of time. You'll have to tune in next time to find out if our contestant has won.
Once is enough. Okay, so those are our videos, which is kind of what we started out as. But as we mentioned, we've embarked on this social media endeavor. So we do post some other posts on Instagram primarily of different formats. So we have funny posts and challenges. So these are the ones, they're sort of like our hook to try and get people in. So just little quirky math jokes and some puzzles, and that will get people really engaged, and it's already kind of showcasing the fun side of mathematics. We also will put out some tips and stats, so drawing on our own experiences, things like tips for doing a PhD or how we have felt studying maths as women and maths anxiety and being in a male-dominated field. and some statistics about women in mathematics, just to raise that awareness and to target people that are already interested in maths and want to know a bit more. And then finally, we have our Women in STEM posts. So we would have regular features of female mathematicians that we have coined "What does a mathematician look like?", where we will show a mathematician, show a woman, and talk about her various accomplishments, including not only her mathematical accomplishments, but other things that she has done. So those are our primary type of Instagram posts. So what is actually next for Mathematicals? What are we working on currently? In the immediate future, so coming up in the next couple of weeks, we're working on something called the 12 Days of Christmas Puzzles. And what that's going to involve is a new puzzle being posted every day. So something not dissimilar to what you can see on the screen. Something easy, but Christmas themed, to get people involved, thinking about maths, solving puzzles. And what will happen is that every solved puzzle, so every time someone sends us a solution to one of our puzzles, this will serve as an entry into our giveaway. So we're going to offer a prize of a Mathematicals branded pencil case, a book by Hannah Fry, mathematician Hannah Fry, a Christmas themed book about Santa, and also just some other goodies. So hopefully this is going to get people engaged, get people talking about mathematical puzzles and making maths fun.
And then we also have ideas for things we'd like to do in the classroom. So although a lot of what we've done has been social media based, partly that's been due to online being the primary platform for everything over the last while. But we actually did have the opportunity earlier this year to partner with the Orlando Math Circle. So in the US, there are these groups called math circles, which basically are groups of usually high school age students. And they're presented with mathematical problems, usually mathematical modeling challenges, and they're just ways to take maths outside of the classroom. So that was really just exactly up our alley. And we had someone from the Orlando Math Circle actually contact us on Instagram. They found our account and they asked us if we wanted to help them develop a mathematical workshop for a group of high school students that they had. So we did that, and really what we tried to do was there was some sort of period of lecturing, in a sense, of us talking to the students, and we tried to show them lots of different maths applications, and we tried to engage them by using an app called Slido, where you can give quizzes and get them to live answer questions. So we tried to make it as engaging as possible. And then at the end of the week, they were presented with a modeling challenge and split into groups, and they ended up presenting it. And we had a great time. We loved working with the students, and we hope they enjoyed it as well. So that's something that we'd love to do more of in the future. And we would also love to bring our content to local schools, whether that's in person or virtually. We'd love to maybe show some of our videos or some of our other content and just talk to students, young people, particularly girls, about maths and about the many things you can do with maths and the many ways it can be used in everyday life. And finally, we'd also love if our content could eventually be used as resources for teachers, because we think many teachers have been faced with the question of when will I ever use this when they're describing a mathematics concept to their students. And it might be nice if they have some resources available that are showing many different ways that many different sort of quite simple mathematical tools can be used to answer many more complex questions. So that's something we're hoping, a direction that we're hoping our content will go in as well. So finally, we'd love to leave you with an assignment from us or a request. We'd love if you'd be able to share our account and our page with anyone in your life you think would enjoy it or would appreciate our content, particularly young people, boys or girls, anyone you think would learn something from our content or would enjoy following us. And probably the best way to do that, we think, is to point them to our website, mathematicals.com. At the moment, that's sort of our hub for all our different social media platforms. And we have a YouTube, an Instagram, a Facebook, a TikTok. We're currently still working out how and what the best ways are to use each of those platforms and how to get them to work together. But we're trying to keep everything focused on our webpage and share all the content that we share on those different platforms on our website. So if you'd be able to share our page with just one person in your life who would enjoy it, that would be fantastic. And we're very appreciative of you listening to us today. And if you have any questions for us, we'd love to answer them. Thank you.
Thank you, Caoimhe and Jess. Are there any questions from the audience, either the in-person audience or on the online? If you have one online, you can put it in the chat if you'd like as well. And I'll start. What's your fraction of male and female followers? Have you tracked that from all of your?
I can check right now. Actually, interestingly, so near the start of when we started putting things out on Instagram offered this a promotion. They said, we'll give you $10 credit to promote a post. So we said yes, and then it asked us what your audience should be, and then it offered the option that it could choose the audience based on your profile. At that point, we had certainly 90% female followers, but the post was about the Mars rover. And when we promoted that with the recommendation of who Instagram thought it would be interesting to, we found that most of, I think it was 100% male people it was sent to. So it actually completely defeated the purpose. It had ignored the fact that we were trying to promote women. It had obviously, the algorithm had picked up NASA, picked up Mars rover and sent it out to male participants. So we thought that was quite interesting. But we can get a breakdown of our followers on Instagram, and it's loading.
Yeah, there's a section to check insights. So we always do find that interesting. We can check our current insights, our sort of follower percentages, where they're from, what gender they are, and we can also check the feedback on individual posts and who that went to.
So at the minute we're 68% women, 31%, 32% men.
It's interesting though that even the algorithm that's sending it out is biasing things towards men. You really are fighting against things here.
Exactly.
And have you found out which of your different types of things that you share is more popular? So out of the, I know you put the funnies on and then you do the longer videos. I like them all, but is there ones that are more popular than others?
It seems to be a little bit all over the place. It's often hard for us to anticipate how well a post will do. Sometimes we'll make something that we're proud of and we put a lot of work into it, and we'll find that it doesn't get much engagement. For instance, some of actually just the very simple posts that we make. Recently we posted one, I think Caoimhe flashed it up when she was showing the different types of content, but it's the acute pie, so it shows an acute angle and a cup of tea and a pie, and the caption was something like what does this mean, or share if you know what this means, or something. And it got, I think, the most likes of any of the posts we've posted, something like 500 or 600 likes, which is much more than we're usually getting on our other posts. So I think sometimes the simpler the better, we found, and we also have found that there's a feature on Instagram where you can post reels, which are the same format as TikTok videos, which are these iPhone aspect ratio videos that you can scroll through, and those seem to do better than videos that are not in that format.
Any questions from the audience? Yeah.
I was just going to ask, is there a preferred person you want this sent to? I mean, is there a preferred person you want to target with your content?
Did you hear that?
No.
Right.
Is there a preferred person that you would want this to be sent to or shared by people in the audience?
I suppose our main target is young girls. So young women or anyone who's still at that point where we could pull them towards maths that haven't been deterred to the point of no return. So we're still finding, you know, we ended up pursuing maths for such a long time and we got to our PhDs. But even we just did that because we liked it. We kept pursuing it and doing more degrees because it was something we enjoyed doing. And I certainly didn't even know until I got to Oxford just how many applications of maths there were and all the different things you could do with it. So had I been thrown off track a bit earlier than my PhD, I would never have found that out. So we're just trying to get the information out to young girls while they're still making decisions about their GCSEs, their A-levels, their general career trajectories.
In your top, I think it was top 10 of scientists on Instagram, they were all male. How far did you have to go down before you hit a female? Did you look?
Yeah, it was the next person on the list, I think.
Oh, was it? Oh, so
There
it
were
was
8
close.
men, and I think number 9 was a woman. At least it was actually quite difficult to find good stats on this. But with the list that we looked at, and then we sort of looked at the percentage of the top 50 science Instagrams was like still maybe about 30% women. So still not great, but certainly the top, once you got down to number 9 on that list anyway, the follower count had dropped off. You've got millions. David Attenborough and Tom Episkay had millions, and then the first woman had a couple 100,000, not very, and maybe not even 100,000. So quite a big disparity in followers.
Yeah.
Do you plan on expanding on any other like social media platforms or anything like that? And you mentioned TikTok style videos.
Do you plan on expanding to any other social media platforms? You mentioned TikTok. That was the question.
I think we're on all the ones we know of, but if anyone has any suggestions for ones they think would be good, we would love that.
I mean, we're on TikTok, but we're very much in the in the low of TikTok. We don't have very many followers. We haven't quite cracked that one. I think we're gonna have to learn some sort of mathematical dance or something that's a bit different from what we've been trying to do, because we have not managed to hit that demographic very well yet.
Which one is your best?
Which platform?
Yeah.
Instagram, I think.
Yeah.
Yeah, I think we post most regularly on that, and often we'll post on Instagram and we'll share that. It will go out to Facebook, I think, automatically. But that's sort of the primary one that we do post on. And then we like any of the videos we've put on that, we also put on our YouTube channel, because we'd like the YouTube channel eventually to almost be the main resource, because that will have all the videos that we've made on it.
Any other questions? No? Okay, in that case, let's thank Caoimhe and Jess, and I think we probably can clap because we have enough people in the audience. Thank you both.
Thank you very much.
Thank you very much.